In this section, we're actually going to get into how to do some calculations with statistics. So we're going to cover your basic calculations here. So section 12.2 is about measures of central tendency. So basically, we're looking at the center of the data. Okay, so central tendency just means the center of that data. Now, there are four main measures of central tendency. So there's the mean, and the mean is what you typically think of as your average, the median, the mode, and the mid-range. Now, I think probably most students know the mean, although you typically use the word average instead. And probably most of you have seen median and mode throughout the years maybe, but mid-range may be a new one. So we're going to go through all four of these. Since each measure of tendency is computed in a different way, it is better to use a specific term rather than just saying average. So again, a lot of times we use average for mean, and you will see that in many other textbooks. Even in Excel, they use average instead of mean, but it is better to try to use the specific term instead. So mean, median, mode, or mid-range. Now, mean is the most commonly used measure of central tendency, so it is used most often. And it is obtained by adding all the data items and dividing it by the number of items that you have. Just for some notation, we use the Greek letter sigma. This is a capital sigma, uppercase. It's called the symbol of summation because what it does is it means to take the sum or to add data values. So you're going to see this symbol in a lot of formulas here. So this here means to add the x's, right? So the sum of all data items, and your data items are your x values here. N in this case is the number of items. So we also think of N often as the sample size. So are investors born or made? It would be nice to think we could all be great, so I should say all be great inventors, but history says otherwise. The following figure, based on a sample of adults in 10 selected countries, shows wide agreement that inventiveness is a quality that can be learned. So in green, and again, this is in your text, maybe easier to see there, shows what % of the country believes that inventiveness can be learned, whereas in orange, it's that inventiveness is inherited. We want to find the mean % of adults in the 10 countries who agree that inventiveness can be learned. So we're looking at the green here in this case. So to find that mean, and the symbol we use for the mean, I think I forgot to include here. It looks like this. It's X bar that represents the mean. So we're going to add up these values. I know it's a little hard to see. So this is in your text on page 787. And it says 92%, 84%, 84%, 80, 78, 77, 77, 77, running out of room, 75, and 75. So I'm going to take those values first. I'm going to add them all up. And I get 799. And then don't forget, you're going to divide by however many values you have. And I have 10 values here. So my answer is 79.9. And this was a percent. So for mean, you're just doing a standard average that you're used to, adding everything up and then dividing by the total number of things. Here I am using a percent symbol because these values happen to be percents. So it's the same units of whatever you're adding up. Now you can also calculate the mean from our frequency distribution. So if you have a standard frequency distribution where each of the values are listed here instead of the classes, so you can do it with classes, but it gets a little bit tricky. So we're just going to focus on kind of the generic frequency distribution here, where you have individual values for your left side of the table. Then you can find the mean, using the table. So what you do is you take the sum of each of the data points times the frequencies. So you're taking the sum, but you're going to do the x values times the frequencies first, and then you're going to divide by the total number of things. Because basically what this is saying is that you have 2 zeros, you have 1 1, you have 3 2s. So instead of writing out this data set, okay, so I have 2 zeros, I have a 1, I have 3 2s, I have 12 3s, It's just too much to write all that out, right? I don't want to have to add up these numbers individually. So the shortcut way to do it is to use our frequencies. So instead of doing 0 plus 0, I do 0 times 2, right? Instead of doing 2 plus 2 plus 2, which is 6, I do 2 times 3, which is 6. So we're using multiplication to help us quickly add up these values. So what you're going to do is multiply all these values straight across to get the total, and then you're going to go ahead and divide by the number of items after that. So you can see that it was started here. So I kind of have part of the solution copied in because it's a lot just to write out. But we're doing 0 times 2, which is 0, 1 times 1, which is 1, 2 times 3, it's 6, 3 times 12, it's 36, 4 times 16 is 64, 5 times 8, 90, 6 times 13 is 78, 7 times 13 is 217, times 31, 8 times 26 is 208, 9 times 15 is 135, and 10 times 14 is 103. And then what you do next is you're going to add these up. And when I add them up, I get 975. Now, we're not done. This is our total. So your mean here is equal to this 975 divided by the number of items. And that is your total frequency. So my total frequency here would be this right here. So if I go back to my original table and I add these all up, what I get is, I think it's 151. Yes, I get 151 data points. So then I take my 975 and divide it by that 151. And I'm going to have to round here. I get about 6.4. Now, this data was about students' stress level rating, so I kind of didn't spend too much time describing that, but it was based on a questionnaire given to students in an introductory stats class. It asked, how stressed have you been the last 2.5 weeks on a scale of 0 to 10? 0 being not at all stressed and 10 being as stressed as possible. And you can see that the mean here is about 6.46. So on average, a lot of the class is feeling pretty stressed, right? 10 is the max, 0 is nothing. So this is 6.5. That's pretty high for the stress level of students in that class. Now, the median is another measure of central tendency, another measure of center, and it is used sometimes, although not as frequently as the mean. But the biggest thing here is you do have to order your data to use the median. With the mean, it doesn't matter the order. You can have it in any single order. It doesn't matter how you add. But with the median, we do need to have things in order. So you do want to arrange things from smallest to largest. And then basically what you're going to do is you're going to find that center of the data. So you're finding actually the middle number. Okay. And again, this means number. So if the numbers are odd, or if there's an odd number of numbers, they'll have a perfect middle. If there's an even number of numbers, though, then you'll take the mean of the two numbers in the middle. So let's do an example. So here's A. So first thing I need to do is order these. So my smallest number is 84, then 88, then 90, 95, and 98. So everything is in order. Now, what I like to do is I like to just count into the middle. So I'm going to count in. So I'm going to take one off the lower, one off the upper, another one off the lower, another one off the upper, and I get to that middle value. So that middle value here is your median. Now, for example B, I do have to put this in order first. I'm going to be really careful so I don't make a mistake here. All right, so my smallest value is 7. Then it's going to be 13 and 15. And then it is 25 and 28. And then 34. And then 47, 59, 68, and finally 74. So you do have to be a little bit careful. And I'm going to count in towards the center. So I'm just going to take off like one at a time on each end till I make it to the middle. All right, now what happens here is I don't actually have a perfect middle, right? I have two values in the middle. So what you do is you find the mean. So we're going over here, we're going to do 28 plus 34 and divide that sum by 2. And what we get here is 31. Now, when we have a lot of data items, it can be a little bit harder to find that middle value, right? If you have like 100 items, you don't really want to be counting in to that center. Just going to take you a long time. Never mind if you had 1,000 items, right? That's a really long time. And I won't lie, we do have technology. For instance, Excel or spreadsheet tools can do these calculations for us, which is helpful if you have large data sets. So our data sets are going to stay pretty small here. But you can also do it a different way. And we can also find the median by using a formula. So in n data items, if they're arranged in order, the median is the value in the n plus 1 over 2 position. So it's not n plus 1 over 2 and that's your answer. That's the position in the data set that the median is going to lie. So let's do example 4. And again, I know it's hard to read here. So this is in your text on page 790. And it says, this table gives the 9 longest words in the English language. And we want to find the median number of letters for the 9 longest words. Now, the information on the left is actually just extra information that we don't need to do the math, but we do need to know the numbers on the right. So the first thing we're going to do, they are basically order, but I'm just going to rewrite it and put it in order. You do want to go from smallest to largest. So my smallest number is 25. Then I have 25. 27, another 27, another 28. I'm going to start writing closer. Actually, you know what? Let's come down here. I'm running out of room. So 25, 25, 27, 27, 28, 29, another 29, a 34, and a 45. So to use this formula instead, the n plus 1 over 2, first of all, n is how many data items you have. So our n here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So our n is 9. So 9 plus 1 over 2 is 10 plus 1 over 2, which is 5. So it's the 5th data point that is your median, not 5. So if I go to my data now, I count into the 5th one. 1, 2, 3, 4, 5. Okay, so this is in the 5th position. So my median is 28. All right, let's do another one with the same formula here. So table 12.8 on the left here gives the mean number of hours and minutes per day spent sleeping and eating in 18 selected countries. We're going to find the median number of hours and minutes per day sleeping. So we're going to focus just on that sleeping column here, not the eating. Okay. As I look at this, I'm actually kind of surprised that the U.S. is up top for some of the longest sleeping. I thought we would have been lower than that. We definitely have some of the lower eating times, though. I guess we rush around a lot of our day, not eating or not sitting for meals. All right. So first of all, how many things do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my n is 18 here. So if I'm using that position formula, that n plus 1 over 2, then in this case, I'm doing 18 plus 1 over 2, which is 19 over 2, and it's not going to come out even. I'm going to get 9.5. So this is the 9.5, I guess, position in the data. Now, I copied some of the solution here just so I don't have to rewrite everything this time. But what you can see is it's been rearranged from smallest to largest. right? So when you're doing the median, you do want to have the smallest here and then the largest here. And we want the 9.5 position. So if I count in, I see 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's the 9th position, and here is the 10th position, right? And I guess 9.5 would be right in between those two. So what you do is you find the mean of those two positions. So we're going to take the mean here. So we're going to add those two together. 8 and 8 is 16 hours. 25 and 27 is 52 minutes. So when I add, I don't have to worry about 52 minutes is still less than an hour, so I don't have to worry about converting anything over here. And when I divide that by 2, I get 8 hours and 26 minutes. So the median number of hours per day sleeping is going to be 8 hours and 26 minutes. So the point here is if you get an example where you have a half position, then again, you're taking the mean of those two middle numbers. So example 6, we have the frequency distribution for the stress level rating of 151 students is repeated below using the horizontal format. So we've seen this data before. We did a couple examples ago where we got that average of about, or that mean of about 6.5 for the stress level. So it's the same data, but we're just using a horizontal table instead of a vertical table, just to kind of mix it up a little bit so you can see how both of them work. So the X values are your different survey options. So stress level from 0 to 10, and your F is your number of students in this case. Okay. So if I add these all up, I do see that N is equal to 151, right? I have 151 students here. So if I want to find the median, this is a great one to use the position formula for because I do not want to try to rewrite this out and count in 151 data points. That's just too much. So if I use the position n plus 1 over 2, I have 151 plus 1 over 2. It does 152 over 2. And then if I go ahead and divide those out, I get 76. So I need the data point in the 76th position. And again, I'm going from smallest to largest. So this is smallest to largest here, right? 0, 10. Now, remember, what's going on here? So as a little side note, we have 2 zeros. So this is like having 0, then 0. I have 1, 1. I have 3 2s. I have 12 3s. Okay, and so on, right? And I need to get to the 176th position. Now, I don't really want to write out 151 data points to figure that out. So I'm going to use my table. I'm going to start counting until I get to 76. So here I have 2 plus 1 is 3, plus 3 again is going to be 6, plus 12 again is going to be 18. Let's see, plus 16. So I'm at 18 plus 16. So I'm at the 34th position. All right, plus 18. So I'm at the 52nd. So here I'm at, let's see, we are at 3. Then when we add this one in, we're at 6. When I add in the 12, we were at 18. After this one, we were at 34. After the 18, we're at 52. So I'm still not at 76. I'm going to add in 13, the next group. And I get 65. And then when I add in the next group, 65 plus 31, see, I get 6, I get 96 after the second group. So if I look here, I want the 76th position. So here I'm at 65, here I'm at 96. So think of it. What's happened is we have 65 data points up through data point 6, right? So all the zeros, the 1s, the 2s, the 3s, the 4s, the 5s, and the 6s, I have 65 data points. Now I start counting my 7s. So my 66th data point would be 7. My 67th data point would be 7. Again, 7. I have 31 7s. And that brings me all the way to the 96th data point. So 76 is in between 65 and 96. So it has to be in that 7th position, right? Because 76 is smaller than 96, so I haven't made it out of the 7s yet, but it's bigger than 65, and I've made it out of the 6s. So I have to be in that 7 category here. So our median in this case is equal to 7. Now, your book does it a little bit differently, so I'm going to show you that page for a second. So they actually take the time and kind of write it out a little bit. So here they write it out by position. So if we have a frequency of 2 here, then you have the 1st and 2nd position. The next count of 1 would be the 3rd position. Here you have the 4th, 5th, and 6th position. And next you have the 7th, 8th, 9th, 10th, 11th through 18th position. So the way I did it is I just had the ending numbers in my notes. So I wrote down the 2, the 3, the 6, the 18, the 34, the 52, the 65. And then I noticed that if I made it through the 7s, I actually got all the way to the 96th position. So I was able to determine that the 76th position is somewhere in the 7s. So this is just a different way to think of it. I did something similar, but I just used the ending values to kind of get me in that ballpark first. So I didn't have to count through so much data. So let's do one more example on the median. It says 5 employees in the assembly section of a TV manufacturing company earn salaries of 19,700, 20,400, 21,500, 22,600, and 23,000. The section manager has an annual salary of 95,000. So we're going to find the median for these 6 people, which includes the manager. So this one is pretty easy in the sense that it's not too many data points. So I'm just going to take a second and make sure I write these in order from least to greatest. And they're actually already in order for us, which is pretty nice. So if I count into the middle here, so I'm just going to use our basic technique here for our median. Let's see, I get about, actually exactly 22,050 here for my median. And again, this one was pretty easy just to counting because I only had 6 numbers, but you could use the position formula here if you wanted to. Now, the second thing it asks for is for me to find the mean. So our mean here is we're going to add up these data points. And then we're going to divide that by 6 because I have 6 data points all together. And when I do this, I get 33,700. So let's just say find. So using these 6 data points, again, just a nice little review here. Here's your median. Here's your mean. Very different values. So your centers do not have to be the same. Now, this is something that is worth talking about. Normally, we use the mean, so your regular average that you're used to most times. It tends to be the most commonly used measure of center, and same thing in statistics as well. We use it a ton in statistics. But there are cases where the median is very helpful, and that's in a case like this. So because the manager's salary is so much larger than all the other salaries, when I compute the mean, it really pulls that mean larger than it should be, right? So if you think about it here, if I were to exclude the manager's salary, then my mean would probably be around maybe 22,000, right? Because people are making between around 20,000 and 23,000. Everyone's pretty consistent. But that manager's salary of 95 is so much larger that it's really throwing that mean score off, pulling it really high. So when one or more data items are considerably higher than the others, or considerably lower as well, it works the other way, then these extreme values can greatly influence the mean. So in cases like this, the median is often used. So although we tend to use the mean most often, if there are 1 or 2 values that are really different from all the other values, the median is often used instead. And this is a great example. So medians are used often when we're looking at income because a few top earners can really sway the mean. So a lot of times if you see data about income, oftentimes they do give you the median salary instead of the mean salary.